looks good. What's up, everyone? Happy Friday. Happy Friday, math nerds. Hope you're having a fabulous afternoon, evening, morning from wherever you're tuning in. My name's Miguel, also known as the Vegan Math Guy, and this is Friday's Off Trail. Typically, we like to go live on Tuesdays, on Thursdays, and on Fridays here on TikTok, but I always post the replays on YouTube. Anyway, today we are going to do some calculus review. I found this test online that a student was going over that they wanted to practice, and I thought it was just kind of fun to look over certain topics of calculus that a lot of people should know. I don't know what this test is specifically. Let's see if I kind of move up. Looks like it's just a Calc 1 final exam from like 2013. Wow, 10 years ago. But anyway, we're going to start off and just kind of doing the multiple choice questions. And if you have any questions that you want to review, please let me know. Typically, Friday is off trail, so I will be here for like at least 50 minutes, and we're just going to review whatever you want, whether it wants to be some integrals or you have specific questions on stuff. That's what we'll do. Off trail, there's no agenda, so we can do whatever we want. Again, let me know in the chat if you can hear me. Hopefully, everything is working. I'm just trying to test things on my end. But everything looks good. Anyway, so we're going to go ahead and get started with this first problem. They give you the functions, and hopefully you can read them. Calc 2. Well, what do you want to do with Calc 2? Let me know, Abel. This particular question is asking, find the open intervals where the function is increasing or decreasing. And keep in mind that whenever we're trying to do that, the very first thing that we want to find is when the derivative is equal to 0. Because that's going to tell us when you have critical points, whether it's going to be a maximum or a minimum. We don't know. So now what we're going to go ahead and do, we already have the derivative for us. It's kind of an easy question, to be honest, because they should have made you take the derivative. That would have been really nice. But you're going to go ahead and set this equation equal to 0. So 4x minus 6 over x cubed is equal to 0. And one of the things about checking for intervals of increasing and decreasing is we don't just want to find when it's equal to 0, but in this case, because this is a rational function, we also want to check when it's undefined. So you set the top equal to 0, 4x is equal to 6, x is equal to 3/2, and you also set the bottom equal to 0. And this one's generally pretty easy. That's just x is equal to 0. So we have 2 points where the function is equal to 0 or undefined. And again, that's going to be important for us. Yes, you do. You have to do some calculus. You just have to know some logic when it comes. I mean, calculus is just a rite of passage. It's fun to do. I kind of cleared the board here so that we can have more space to work on. So now that we found the points, we want to go ahead and test the number line. A lot of people like to do tables. I like the number line because I have my x values. This is 0 and this is 3/2. And so we're going to go ahead and test points in between, to the left, in between, and to the right. So we're going to test -1. We're going to test 1, and we're going to test 2. And we're going to plug these into our derivative because our derivative is going to tell us whether or not the derivative is positive or negative. In other words, it's telling us whether the function is increasing or decreasing. So let's go ahead and test f of -1, or f prime of -1, I'm sorry. So you plug it into the derivative function. So that's going to be 4 times -1 minus 6 over -1 cubed. This is -4 minus 6 over -1. And the cool thing about this is we don't necessarily care about what the value is. We just care if it's positive or negative. In this case, it's -10 over -1. It's 10. It's a positive 10. So I'm going to go ahead and put a plus in this interval. So right now, that's telling me that the function is increasing. I'll do a problem in area coordinates just after this, okay? I'll pull one up. So stay tuned, Abel. After this problem, I'll do a problem in polar coordinates. Again, Fridays is off trail, so anything goes. All right, now we got to test 1. So I'm going to go ahead and plug it into the derivative. 4 times 1 minus 6 over 1 cubed. That looks like it's -2 over 1, which is -2, is negative. So in the number line, I'm going to go ahead and put a minus there. And now we're going to go ahead and plug in 2. 4 times 2 minus 6 over 2 cubed. That's 8 minus 2 over 8. Again, we don't necessarily care about the value, just whether or not it's positive or negative. So 2/8. That's going to be positive. So up on my number line, that means that to the right of 3/2, my derivative is going to be positive. Now, what does that tell us? That tells us that the function is increasing. Starting from the beginning, I'm even going to draw kind of how it looks. We don't know if this is correct, but at 0, it's undefined technically. So the function is increasing at some point, and then it's decreasing here, and then it's increasing. So that means that all they were asking for, I believe that question is asking the open intervals where the function is increasing. So we're going to say that it's increasing from negative infinity to 0, union 3/2 to infinity. And where is it decreasing? Well, that's just going to be from 0 to 3/2. All right, that's how we find whether or not a function is increasing or decreasing. There's other points or other ones where they might want you to find the concavity, and it's actually part B. That dude, listen, man, TikTok is all about just trying to find and learn stuff. I know that TikTok can be trash sometimes, but there is a lot of educational content out there. Anyway, guys, someone requested polar coordinates. That's what we do on Fridays. We take any requests. We go ahead and do some off-trail math. It doesn't matter. Anything goes. So I'm going to go ahead and pull up a problem. I'm going to remove this. I'm going to close this off. I'm going to stop sharing for now. Go ahead and talk amongst yourself. I'm curious where everyone is tuning in from. Where in the world are you at? Where are you holding your phone and looking at the screen and solving math problems with us? Let me go ahead and erase this. Okay, guys, it's funny. I wasn't expecting to pull up my whiteboard or my blackboard here, so just give me 1 second. I'm going to pull it up. Where is it at? This is why I have multiple screens here on my end. Okay, this is my blackboard. The reason why I want this is because Abel requested a question on finding area of polar equations, and I'm actually going to go ahead and pull this question here. This is from an AP exam. Funny that you were just talking about. I was just talking about this with another student. Okay, let me know if you can't see it. I'm actually going to go ahead and write a little bigger on here so that we can see what I'm trying to show. But this is a typical free response question. MVT, I will do mean value theorem right after this. Anyway, so Abel requested an equation involving polar coordinates. That's exactly what we're going to do. So what you have here is in a free response question, you're going to have two polar equations, and they want us to find the region of this function r. Okay, this is in polar coordinates. Luckily for us, I'm going to write this down a little bit bigger, but they tell us where these points intersect, or not the points, but it's going to be the angles, and it's at pi over 3 and 5 pi over 3. So we have a couple things here. We have theta is equal to, maybe I can write a little higher up here. Yep, theta is equal to pi over 3 and 5 pi over 3. So if I were to draw this function, it looks kind of like this. And we are trying to find this region R. Pi over 3 is up here. And 5 pi over 3 is up here. And the functions that these represent are r equals 3 plus 2 cosine theta. And then the other one is going to be, what do they tell us? R is equal to 4. Okay, so one of them is a circle. The other one is going to be this cardioid, or this butt, like people like to call it. All right, so what we have here, the circle is going to be the r is equal to 4, and this butt-shaped looking thing is going to be 3 plus 2 cosine theta. So whenever we want to find area of polar coordinates or polar equations, it's just like areas of regular equations that we're used to doing. We are going to go ahead and take 1/2 from a to b, or the integral from a to b, of the first function squared minus the second function squared, d theta. If you notice, this is kind of like Washer method. So the first function is going to be the one on the left. That's going to be the circle, because that's going to be the larger value. So that's what I'm going to go ahead and plug in. 1/2 integral from pi over 3 to 5 pi over 3, because those are where the coordinates are intersecting. And we have 4 squared minus, and now we're going to have the cardioid, the butt shape. So that's going to be the other equation. 3 plus 2 cosine theta squared d theta. The setting up part is actually really easy. Okay. Now that we have that, I'm actually going to get rid of this so I can create more space on the blackboard. If you're familiar with any of my lives, we always are making space in the blackboard here because there is so much to write. But hopefully you got the idea of what the polar function looks like. So now we have that equation. Okay, so now we're going to go ahead and simplify this. We have 1/2 integral from pi over 3 to 5 pi over 3 of 16 minus, and now we have to use the FOIL method on that particular equation. So that's going to be 9 plus 12 cosine theta plus 4 cosine square theta d theta. Notice that I'm very careful with my parentheses there because we're going to go ahead and distribute that parentheses. And while I do that, I'm actually going to go ahead and combine the 16 minus 9 at the same time. So I have 1/2 integral from pi over 3 to 5 pi over 3 of 16 minus 9 is 7. Geez, I can't add there. Minus 12 cosine theta plus, or minus, I'm sorry, 4 cosine square theta d theta. Okay. Arturo, I think you're coming in here. Oh, I remember this integral. Okay, we'll probably try to do that one after. So funny. Andrew, that's awesome that you're a private math tutor from California. I'm a private math tutor from all over the world. I have students in Italy. I have students in I think it's Spain. I'm not quite sure. The time zone's a little different, but that's awesome, dude. Okay, hang on tight. We're going to do that integral for you, Arturo. Where am I getting the 1/2 from? This is the general equation for the area of a sector. So whenever you have, hold on, it looks like I erased things. Whenever you have polar coordinates, this equation is how you find the area of the sector. So it's the integral of 1/2 integral from a to b of r squared d theta. All right, so let's go back to this one. We're easily going to take the integral of a couple things here. I'm actually going to separate it because this last integral is going to require a little more work. So I'm going to have 1/2 integral from pi over 3, 5 pi over 3 of 7 d theta minus 1/2 integral from pi over 3 of 5 pi over 3, 12 cosine theta minus 1/2 integral of pi over 3 to 5 pi over 3, 4 cosine square theta d theta. The first one's generally is going to be pretty easy. That's just 1/2 7 theta from pi over 3 to 5 pi over 3 minus 1/2 this integral 12 cosine theta. That's just going to be 12 sine theta pi over 3 to 5 pi over 3. But how do we find this last integral? We have the integral of 4 cosine theta. I'm going to move this a little bit so that students can see it because I know some people can't read it because of the comments. So hopefully you can see it now. How do we take the integral of this last one? I saw Eric came in and said, we are going to do the reducing formula. And that reducing formula is this one. Let me write it in red. We have to do cosine square theta is equal to 1 plus cosine of 2 theta over 2. That is a reducing formula. That is one that you should definitely memorize. Okay, so I'm going to go ahead and rewrite that. I still have 1 minus 1/2 integral from pi over 3 to 5 pi over 3 of 4 times 1 plus cosine 2 theta over 2 d theta. Okay, let's simplify some stuff. Let's just get rid of it. Let's just figure this out already. I'm just going to introduce or implement the first fundamental theorem for both of these terms. So I'm going to have 1/2, and this is going to be 35, because I'm plugging in the 5 pi over 3. 35 pi over 3 minus 7 pi over 3 minus 1/2, and now I have 12 sine of 5 pi over 3 minus 12 sine of pi over 3. Okay, let's just go ahead and finish integrating this last integral so we don't have to worry about this. We technically have two terms. One of them is being added together, the 1, and then well, first I'm going to go ahead and split this. So 4 divided by 2 is 2. I'm going to bring it outside. So it's going to multiply to the 1/2, so it's going to be gone. So I don't have to worry about that anymore. So now what I'm going to do is I'm going to take the integral of 1, which is theta, and I'm going to take the integral of cosine, which is going to be 1/2 sine of 2 theta, because I'm using u sub. I don't want to show all that work here. Technically, when you're doing Calc BC at that point, you should know that. So this is 1 or minus theta plus sine of 2 theta over 2 from pi over 3 to 5 pi over 3. Okay, let's continue simplifying, and then I'll make some more space. Actually, let's do that now. Let's make some space on the blackboard. Here we go. Screw it. It's going to look a little funky. Actually, let's do it again. I don't like when things are left out. There we go. Much better. Let's make this a little smaller. Nice. Okay, so let's simplify that first parentheses. 35 pi over 3 minus 7 pi over 3. That's going to be 28 pi over 3 minus 1/2. 12 sine pi over 3. That is going to be negative root 3 over 2. So this is 12 times negative root 3 over 2 minus 12 sine pi over 3. That's 12 root 3 over 2. Got to know your unit circle. Minus, and then we're just going to go ahead and plug in the rest of these. So this is going to be 5 pi over 3 plus sine of 10 pi over 3 divided by 2. Minus pi over 3 plus sine of 2 pi over 3 divided by 2. Oh, goodness, guys. You can already see that this is going to get pretty messy. I'm just going to, because I want to touch on other problems at this point, we just kind of simplify this using common denominators, unless you want me to continue simplifying it. If we feel good and we can move on to a different type of problem, then we can do that. Let me know in the chat if you feel like you want me to reduce it or just move forward. If we got the gist of it, we can do another problem. Abel said move on. Abel requested it, so we're definitely going to move on. All right, I'm going to go ahead and write the other problem. Okay, double integrals are going to be coming. Maybe I think we have some time to do those. Let me go ahead and erase this. I am going to go ahead and do one that Arturo requested. And Arturo, I'm going to write it out. If I wrote it out wrong, let me know, okay? We have the integral of 3 over x root x squared minus 4 dx. Why do I have a feeling that's going to be somewhat messy, but we'll see. Anyway, guys, as we're doing this, you're very welcome, Abel. Go ahead and let me know. Where are you guys tuning in from? I'm here in Washington. Today it is sunny. We're supposed to have 60-degree weather, and we're probably going to sunbathe, which is so weird. And then after that, back to the rain. Awesome, Arturo. Houston, let's go. Okay. So Ryan already said that it looks like it's going to be a trig sub, and I completely agree that it does look like trig sub. Things that give it away is you have a root on the bottom with like a nice quadratic, and then you have the x on the outside. I almost feel like this is going to be a general arc secant problem, or an arc. It could be an arc sign, but it's one of those, okay? I think at this point, some people are probably just going to memorize it, but let me work it out and see how this looks. Again, it looks like a trig sub problem. If you try u sub, it probably won't work. So let's go ahead and draw out my triangle, because one of the things that you should be able to kind of understand, if we're going to start with trig sub, this right here has the variable squared minus 4. That's going to be a great setup for an arc secant, okay? So what this happens is you want your x or your variable to be equal to secant theta. Here's what I mean. I'm going to draw out my triangle. I'm going to go ahead and put my x here, and I'm going to put my 4 here. This is my theta, and then using Pythagorean theorem, this is x squared minus 4, and this shouldn't be 4, it should be 2, because you're going to square it. Okay, think about that. Try to work out the Pythagorean theorem, and you're going to see why that's the case. Anyway, let's continue. So this is what I mean by this. If we do some trig identities here, secant, if you recall, is equal to the hypotenuse over the adjacent. It's the reciprocal of cosine. So this is why I wrote it as x over 2. Let me move the 2 to the other side. So we have 2 secant theta is equal to x. This is beautiful. And now we're going to go ahead and take the derivative. So we have 2 secant theta tan theta is equal to dx. Okay, that's helpful. And now we're going to do one other one. I'm also going to use, let's go ahead and do, not sine, I'm sorry, tan theta is equal to, looking at the triangle, opposite over adjacent, so that's x squared minus 4 all over 2. So if we multiply the 2 to the other side, we get 2 tan theta is equal to root x squared minus 4. And now this is a perfect example. I think we are ready to go. We're going to go and move on to our integral, and that's where we're going to replace and substitute everything that we created. So it looks like I have the integral of 3 over our x value. Look at this. 2 secant is equal to x. Beautiful. So we're going to do 2 secant theta times the root of x squared minus 4. Look at this. That's 2 tan theta. So 2 tan theta. And then one thing that I totally forgot when I put my, and then I need my dx, obviously. I haven't written that. So now I need my dx. That's over here. 2 secant theta tan theta. And there should be a d theta there. Let me put the d theta right after this 2 secant theta. So now I'm going to put times 2 secant theta tan theta d theta. And I know it looks a little bunched up, but let me make, actually no space on the blackboard just yet. Let's just move this downward and let's simplify. The 3 is going to go on the outside. Let's just do that now. Integral of the 2's cancel out, which is great. Twos cancel out. And Ryan, I'll talk about how we determine what goes there, okay? It's all about just kind of messing around with it. Secant and tan theta cancels out with the secant and tan theta that's down here. And all we're left with is the 2. So I'm just going to bring it on the outside. Yo, check this out. All we are left with is 3 on the outside, the 2 on the outside, and d theta. And if we take the integral, that's just 3 halves theta plus c. And you can say we're done. But then we need to rewrite this in terms of x. And what do we use? The original value that we had. Secant theta is equal to x over 2. So if we take the arc secant of that, we're going to get theta is equal to the arc secant of x over 2. And that's exactly what we're going to plug in for our theta out here. So then the answer is 3 halves arc secant of x over 2 plus c. This is one that you should definitely have memorized. What gives it away is you had x squared minus 4, and then the x on the outside immediately tells you that it's going to be an arc secant. Okay, I'm looking at the chat. Someone asked, how do you determine what value to put there? I think that's an excellent question to ask. And so you're going to have 3 options. Let's kind of review that whenever you have trig sub, okay? Let me go ahead and erase this real quick. It's not erasing them. Oh, there you go. Couldn't erase on my iPad there for a second. Now, you have 3 options. We're going to use arc secant whenever we're using trig sub. The best ones, at least the optimal ones, are arc secant, arc tan, or arc sine. Now, how do we know which one to use? If you have x squared minus a squared, notice that you have, let's just say it's a root. It doesn't matter. What I'm trying to tell you is that if you have a problem like this, if you have x squared minus a squared, and if you're running with, if you're trying to run with trig sub, when you set up your triangle, again, you have the variable squared minus a squared. We're looking for a secant. You want to make your hypotenuse the variable and your adjacent your a. Because when you do secant, that's an easy x over a. Hypotenuse over adjacent. So you multiply the a to the other side, and then we're done. See how beautiful that is? And then from there again, you're going to have to use Pythagorean theorem, but then you get x squared minus a squared here in your opposite side. Okay, now let's talk about this one. A squared minus x squared. Yes, thank you, math nerd. It should be dx, not d theta. So what happens when you have a squared minus x squared? Okay, notice it's a little different, right? The variable's first in this one. The variable is being subtracted here. This immediately should tell you that this is going to be an arc sine. Okay, so when I'm thinking sine, when you think of like the triangle there, it is opposite over hypotenuse. So you want to set it up. Your hypotenuse is a, and your x is going to be your opposite, because if you do sine theta, that's x over a. And if you multiply the a to the other side, you get sine theta is equal to x. And that's beautiful. And once again, you use Pythagorean theorem to do a squared minus x squared. And then the last one, if you have 1 over x squared plus a squared being added together, so that's just going to be an arctan. Okay, so then you make your opposite your x, your adjacent your a, and then your hypotenuse is your x squared plus a squared. Okay, get comfortable with these. This is something that you're going to see often. This is something, I mean, whenever you see some crazy integrals, this is what you see all the time. And you should kind of just be able to identify those things. It's all about just being prepared. Okay, so practice these as much as you can. Pull out, I mean, there's so many problems out there, but you can just Google trig sub integrals, and you can work your way through those. Yes, yes. Math nerd, thank you. Yep, it was, I put d theta there on accident, but it was a dx. It's all variables. Perfect. Okay, I'm just going, again, today Fridays are off trail. Anything goes. We're just talking math for the fun of it on St. Patty's Day. And I saw someone, May Sky, said, can you find the limit as x approaches 1 of 2 minus x over x minus 1 squared? Okay. Hopefully that's correct. If that's the case, one of the things that you should always try to do when it comes to limits. Yeah, you're welcome, Ryan. When you're doing this, just make sure that you first do direct substitution. What is that? Just plug in 1 and see what you get. 2 minus 1 over 1 minus 1. Oh, this is an issue. Because what are you getting? That this is going to be undefined. Because look, you have 1 over 0. That doesn't exist. There's not even an indeterminate form. So we can say DNE. One of the things you should always do is always test for your integral, because you don't want to encounter a situation where you immediately jump to L'Hopital's rule and then it doesn't work, or you get a different answer. All right, guys, let me go ahead and erase this. I don't know. Oh, someone said a double integral. Let's go ahead and do some of those. Give me 1 second. I'm going to go ahead and pull it up on my end. Okay, I am here for at least another 20 minutes, and then I do have to go, unfortunately. But I'm always here on Tuesdays, Thursdays, and Friday around this time, 3 p.m. Pacific time. Let's go ahead and do a double integral. I'm just going to do a double integral example. These are just fun. Let's try, why not this one? We have integral from 0 to pi over 2. Integral from 0. Nah, that's too easy. You're going to see I didn't want to do that one. It is way too easy. But we'll kind of start off with this one. 0 to 1 integral x squared, I believe. X squared to x of x plus 3 dy dx. This is a typical double integral that they, start like kind of warming you up with. Okay, and after this, I'll do mean value theorem. And mean value theorem is so simple, so easy. This is technically Calc 3, yes. So this is the way it's going to work is if you already know how to take some basic integrals, you can easily do a double integral. Okay, setting it up could be a whole different story. But when we have something like this, you always want to start off with the variable that they tell us first. They tell us that you're going to take this in terms of y. And the way we do this is we treat every variable that's not a y like a constant. So when we take the integral of x, just imagine if that's the constant. Think of it like if it was a 6, then the integral will be 6y. If it was a 7, the integral will be 7y. So this is going to be xy plus 3y. In other words, we can just do x plus 3y if you wanted to. Okay, we have the integral from 0 to 1, and we're still implementing the first fundamental theorem of calculus, and we're including the x squared and the x. And now let's go ahead and do that. So for the first one, we get x plus 3, and then I plugged in that x, minus x plus 3, and then I'm going to go ahead and plug in the x squared. I guess I should put it in green too. Make it nice. Okay, let's simplify this. This becomes x squared plus 3x minus x cubed minus 3x squared dx. And now I can go ahead and combine the x squared and the minus 3x, and I get integral from 0 to 1 of negative 2x squared plus 3x minus x cubed. Okay, it's not in standard form, but that's fine. All right. Let me just kind of simplify this. Now we have negative 2/3 x cubed plus 3x squared over 2 minus x to the 4th over 4 from 0 to 1. You're going to plug in 1 into everything. And that's just going to become negative 2/3 plus 3/2 minus 1/4. And check this out. When you plug in 0, everything is just going to become 0. So we're just going to subtract by a big fat 0 at the end. And now you just got to get some common denominators. Looks like the common denominator should be 12. So we have negative 8/12 plus 18/12 minus 3/12. And that's what? I think that's going to be 7/12. And that's the integral there. Arturo, yes, I upload the replays on YouTube. I try to do it as soon as I'm done here. I try to download it if TikTok allows me, and then I post them on YouTube. So you guys are welcome to do that. I mean, there's plenty of lives out there that I do. And, of course, if you always have suggestions, let me know so I can create some videos for that. This is technically Calc 3. Okay, I'm going to do a different integral that someone requested here, and then I'm going to do some the mean value theorem, and I think we might be done just for today. I know today was a short one. I was kind of running late, and I have a great excuse for that. Okay, so this is, yeah, let's go ahead and do Mace Guy. This will be an antiderivative. So let's go ahead and recreate this. So 1 over x root 4x squared plus 9 dx. Okay. And as I'm writing this, I would love your suggestions. If not, let me know where you're from. As you're doing that, don't forget to like this video, follow me here on TikTok, follow me on Instagram, subscribe to my YouTube channel. And if you always want to support what I do, this is what I do for a living, please just consider, looking at one of my digital books. They're all online. They're, very inexpensive, and I think they're super helpful for a lot of you guys. Or just continue following me. That alone is the support. You guys help me get brand deals, which is great. Okay, looking at this, guys, what do we suggest? What should we do in order to solve this? We have 1 over x root 4x squared plus 9. Someone said u sub. Let's try u sub. I'm just going to try u sub because I don't even know if that's correct or not. But let's try it. So I'm assuming if we make u sub, we're going to make the u equal to the 4x squared plus 9. So u is equal to 4x squared plus 9. Du is equal to 8x dx. And then so du is equal to 8. Du over 8x is equal to dx. But look what happens. I have integral of 1 over x root u times du over 8x squared. Or 8x, I'm sorry. When I simplify this by multiplying the 8x and the x together, I get du over 8x squared root u. That doesn't quite simplify, right? So it's always good to just check. Aiden's already kind of like jumping in the answer, which I think they might be correct. But I always suggest check the work, okay? Because you're never going to learn whether or not this is correct. So it's almost like, think of it like you're driving down the road and you don't really know where you're going. Take one turn, and if you hit a dead end, then just turn back around and restart. So that's exactly what we're going to do. U sub didn't work, so now we're going to try the other technique that a lot of us will become familiar with, and that's going to be trig sub. It's funny, we just talked about this. Things are being added here together. So it looks like I'm going to make my triangle, and it's going to be an arctan. So 2x is on my opposite, and 3 is on my adjacent. Because when I square this, it's going to be 4x squared, and then when I square the 3, it's going to be 9. Okay, and if you go ahead and do the Pythagorean theorem, this will be root 4x squared plus 9 there in my hypotenuse. And so now what do we do? We're going to do tan theta is equal to opposite over adjacent. So we're going to do 2x over 3. Let's bring the 3. Let's multiply 3 to the other side and divide by 2 at the same time. So that we have this 3/2 tan theta is equal to x. So now we can take the derivative. 3/2 secant square theta d theta is equal to dx. And now what we're going to go ahead and do is we need to find a common or an equation for this root 4x squared plus 9. Well, that's the hypotenuse. I'm just going to use the 3 because I don't want to include another variable. But now that's going to be hypotenuse and the adjacent. So that's going to be either cosine or it's going to be secant. Secant theta is root 4x squared plus 9 over 3. I prefer secant because the variable will be on top. So when I multiply the 3 to the other side, I get 3 secant theta root 4x squared plus 9. And now we're going to go ahead and rewrite our integral. So we have 1 over the x value. That's the 3/2 tan theta. 3/2 tan theta times the root. That is this one right here, 3 secant theta. 3 secant theta. And then times our dx, which is going to be this right here. So this is going to be 3/2 secant squared theta d theta. So let me just kind of move this. You'll notice that the 3/2 cancel out. That goes away. There's going to be a secant on top, and the secant on the bottom cancels out because there's 2 on top and 1 on the bottom. So that secant cancels out, and then we're left with only 1 secant. And at the same time, I'm going to bring the 3 to the other side, or outside of the integral. It was on the denominator, so it's going to become 1/2. Now 1/2, 1/3. So now we have integral, or 1/3 integral of secant theta over tan theta d theta. Okay, I'm going to go ahead and create some space on the blackboard here. And as I'm doing that, go ahead and tell me what would I do next, because I don't know the integral of this. But I'm curious to see what other people can tell me. What do you mean by factor 9? I think I just took the square root of 9, made it a 3. Tristan. Right, in terms of sines and cosine. Let's go ahead and do that. Let's go ahead and rewrite that. We have 1/3. I'm going to rewrite the secant as 1 over cosine. Oh, I kind of know where this is headed. And then tangent is sine theta over cosine theta. Y'all, and a lot. This is so interesting. A lot of people have trouble dividing these things, but just remember that this is the same thing as 1 over cosine divided by sine over cosine. And it says, like, going back to our very sixth grade math. This is keep, change, flip. So this is 1 over cosine theta times sine cosine theta over sine theta. So that you'll notice the cosines cancel out. So this integral here is 1/3 integral of 1 over sine theta d theta. E. And I think this is a very important integral we should know. Let me rewrite it, because 1 over sine theta, don't really know what to do. This is going to be 1/3 integral of cosecant theta d theta. And this is a common integral that we should kind of be familiar with. This is the unfortunate part. Sometimes we just have to remember some tricks, because then you're going to have to do some extra work. But who can tell me what this integral is? The integral of cosecant theta. Integral of cosecant theta. Burner, there we go. So it's this. It's negative. So I have the 1/3, by the way. 1/3 times negative natural log of cosecant theta plus cotangent theta. This one and the integral of secant theta are ones that we should remember. Okay, it's not that it's difficult to prove, but it's one of those things like if you have it memorized, then you're gonna be good to go. It's kind of like memorizing the integral of tan because you don't want to continue doing u substitution every single time. But let's go ahead and make this smaller because we're not done yet. Yes, we found the integral, and yes, I didn't put a plus c, but that's what I'm gonna do in a second. Let me just go ahead and move this on the other side or make this a little smaller. Everyone talk amongst yourselves. Okay, let's move this. So now what we have is we have negative 1/3 natural log of cosecant theta plus cotangent theta plus c. But again, this is in terms of theta, so we have to go back and find what cosecant and cotangent is. Cosecant theta, looking at the triangle, cosecant is hypotenuse over opposite. So it's going to be the hypotenuse over the opposite. So we're going to have negative 1/3 natural log of hypotenuse, which is root 4x squared plus 9, over the opposite, which is 2x, plus cotangent. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so it's just going to be adjacent over hypotenuse, or adjacent over opposite, my bad. So this is 3 over 2x plus c. And if you want to get fancy, we can go ahead and just get everything under a common denominator, 4x squared plus 9 plus 3 plus c. Yo. Beautiful. Abel, quick, that's a great question. So here's what I do. People are always asking me this in the comments and sometimes in the live too. This is unfortunately, I wish I had I can stream like an actual streamer on TikTok, but I can't yet. But I am filming on my phone. That's showing my screen here. I have a Zoom here, and this is a whiteboard that I'm sharing my screen to my Zoom. And look, this is where I'm writing. I'm writing all my stuff here. So whatever I write goes on the screen, which is really sick. When did I become vegan? Like 7 years ago. Honestly, I did it just because I felt like I was overweight and I didn't want to eat fast food. And I'm hard on myself, so I said the only way I can do it is if I have to force myself to eat fruits and vegetables, meaning that I have to go vegan. And that's what I did. And now it's just been a choice. To me, I just don't want to consume animals, which is fine. And if people do, that's fine too. But to me, it's just not my thing anymore. But that's why. First, it was for health, and now it's just ethical reasons. Yes, Microsoft Teams will also work as well. Yeah, I want to get the TikTok studio thing. I want to be able to have a stream key so I can stream on there. This was, I think, the last problem we were going to do today because I do have to sign off. I have a couple students that I'm meeting with privately. As you know, this is what I do. I guess you can say almost half of my time, part-time. And then the other half is I'm always doing private sessions. So I am a private tutor where I meet people or I meet with students in California. I have some in Florida. I have some in New York. I have some in Spain, one in Italy. And on the other times, I'm always filming content for you guys and I'm going live. Yeah. Abel, right on, dude. Yeah, join the Discord, guys. If you go to the link in my bio, you're going to see a bunch of resources. Yeah, I am on YouTube. I am on Instagram. I am on TikTok. I do have a Discord where people can chat with other math nerds. And I have a bunch of resource books. I've written 4 books that I think are really cool. So take a look at them. If you guys want to continue supporting, please follow because that's great for for brand deals, and I can create more content for you guys. But if you guys ever find it in your hearts to support in any way, I always appreciate it. Anyway, I'm going to head out. Happy St. Paddy's Day. I am going to chill at home watching YouTube podcasts, which will be amazing. I'll probably solve some new integrals. Be on the lookout for an integral that someone challenged me to solve. I'm just going to write it real quick. I don't know how to do it, but it's this right here. I think I found a solution, but I'm going to post it on my Instagram and see if people can correct me. Nice. Hope that test went well. Do I have any advice before an exam? To be honest, one of the things that will help me is Obviously, prepare. That's a huge thing. But at the same time, I used to pretend to teach myself the material, kind of like I'm doing now. I'm talking to an audience, but I will just talk to the wall. It's a little silly, but I will talk to the wall and explain the material, and eventually it just makes a lot more sense. When it comes to math, I was obsessed with it. Some people are not, but that's my suggestion. Study as much as you can, practice as many material as you can, and of course, try to teach it to someone, even if it's to a wall, because they don't make sense to you. And then, of course, get some sleep, especially during like the AP exam, a large big test. One of the things that I always like to do, I don't know if you guys ever ran like a marathon or have heard of something called tapering, but you study for days, and usually the day or 2 days before, you should be doing nothing. You should be thinking. You should be on the couch just chilling, because you're letting your brain taper and then process all the information. So, cramming the night before, sometimes not the best, but I always tell students whenever they log off is have some food, chill out. At this point, you did the studying. I mean, just let your brain relax. The next day, just kick some ass. Anyway, guys, I'm going to head out. I hope you guys have an amazing weekend. Don't forget that I'm here on Tuesday. We are going to do some integration B problems. Any integration type problems that goes, I'm going to have a list of like 10 integrals that hopefully I can fulfill and complete. And then every day, every week on Thursdays, and then here on Fridays. As you already know, you can always follow me here on TikTok, on Instagram, subscribe to my YouTube channel, or check out all the resources that I have. I appreciate you all. You guys are the best. I can't believe that there's 40 people on here talking math. It's beautiful. And you guys are amazing for that. Anyway, I am going to head out. Hope you guys have a great weekend. I'll see you guys next week. See ya.